Section 4. Evolutionary succession and preservation of technicity, law of relaxation. The evolution of technical elements can have repercussions for the evolution of technical individuals. Composed of elements in an associated milieu, technical individuals depend to a certain extent on the characteristics of the elements they implement. Electric magnetic motors can thus be much smaller today than in Graham's days, because magnets have been greatly reduced in size. In certain cases, elements are like the crystallization of a preceding technical operation that produced them. In this sense, magnets with oriented grains, which we refer to as magnetically tempered, are obtained through a procedure that consists in maintaining a vigorous magnetic field around the molten mass that, once cooled, will become the magnet. Starting with the magnetization of the molten mass at a temperature above the Curie point, its intense polarization is then maintained while the mass cools. When the mass is cooled, it constitutes a far more powerful magnet than if it had been magnetized after cooling. Everything happens as if the vigorous magnetic field produced an orientation of the molecules in the molten mass, an orientation that maintains itself after cooling, if the magnetic field is sustained during its cooling and transition into the solid state. Now the furnace, the melting pot, and the coils creating the magnetic field altogether constitute a system that is a technical ensemble. The heat of the furnace shouldn't have an impact on the coils. The induction field creating the heat in the molten mass shouldn't neutralize the continuous field aimed at bringing about the magnetization. This technical ensemble is itself constituted of a certain number of technical individuals that are organized in relation to each other, both in view of the result of their functioning and so as to prevent the conditioning of each particular functioning from being disturbed. In the evolution of technical objects, we thus witness a passage of causality proceeding from prior ensembles to subsequent elements. Such elements, once introduced into an individual whose characteristics they modify, in turn enable technical causality to rise from the level of the element to that of the individual, then from the level of the individual to the level of the ensemble. Here in a new cycle, technical causality once more descends to the level of the element via the process of fabrication, where it reincarnates itself in new individuals and then in new ensembles. There is thus a lineage of causality that is not rectilinear but serrated, where one and the same reality exists first in the form of an element, then as the characteristic of an individual, and finally as the characteristic of an ensemble.
Yeah, I mean, if I remember correctly, that harkens a lot. I not read this because it's not an English read, but Psychic, Collective, and I forget the last names. It's all in French, but that book where he talks about crystallization, right, and going from the pre-individual level to the trans-individual level, it sort of reminded me of that, right?
Yeah, this image of crystallization is something that's very important in that book as well, and in his work in general. So yeah, he's sort of drawing on that here.
Yeah, because if I remember, ensemble is so. What is he referring to that in terms of ensembles? It's not really trans-individual in this case, then.
No, so we looked at this a little bit last time, but he's going to develop it further, I think, in today's reading. So he divides up technical objects into three levels. So you have the element, the individual, and the ensemble. So the sort of fundamental one is the individual. The other two are defined in terms of the individual. So the technical individual is a technical object that has an associated milieu. So it's individuated and it has a certain environment in which it functions. And then an element is a technical object below the level of the individual, so a component of a technical individual that is not itself an individual. And then an ensemble is something that contains an individual but is not itself an individual. So those are the three levels of technical objects. So an ensemble is an organization that contains technical individuals, but is not itself an individual. Okay, would someone like to read the next paragraph?
Yeah, I don't mind going ahead. The historical solidarity that exists among technical realities is mediated by the fabrication of elements. For technical reality to have posterity is not enough for it to simply improve in itself. It must also reincarnate itself, and participate in this cyclical coming into being via a process of relaxation within the different elements of reality. The solidarity that exists among technical beings masks the other much more essential solidarity that requires the temporal dimension of evolution. Not identical with biological evolution, however, which in turn is not characterized by these successive changes of levels and which occurs along more continuous lines. If transposed into biological terms, technical evolution would consist in the fact that a species would produce an organ that would be given to an individual, which would thereby become the first term of a specific lineage, which in turn would produce a new organ. In the domain of life, an organ is not detachable from the species. In the technical domain, an element is detachable from the whole that produced it, precisely because it is fabricated, and here we see the difference between the engineered and the produced. In addition to its spatial dimension, the technical world has a historical dimension. Its current solidarity mustn't mask the solidarity of succession. This later solidarity is in fact that what determines the great epochs of technical life through a law of serrated evolution.
So yeah, here he's proposing a law of evolution of technical objects, or a theory of the evolution of technical objects through these different levels of reality that he's pointed out. So the technical individual, it leaves a posterity, or it founds a lineage not through other individuals but through elements. So it's the elements of a technical object that is transmitted to a future generation and then becomes an element of a different technical object. So you have a process of evolution where an element is incorporated into a new technical object as its descendant, which is incorporated into an ensemble, which then creates a new element, and so on. So you have a cycle between between an element, an individual, and an ensemble, and then back to a new element.
Yeah, I think it's so he contrasts that with the fact that human organs, in the domain of life, an organ is not detachable from the species. In the technical domain, an element is detachable from the whole that produced it, precisely because it is fabricated. And here we see the difference between the engendered and the produced. Yeah, I think that line sort of explains it pretty clearly with regards to this short little paragraph.
Yeah, so he's contrasting technical evolution and biological evolution. So yeah, biological evolution is the evolution of species happens through the generation of individuals, whereas in technical evolution it happens through this cycling between individual, elements, and ensemble. Yeah, would someone else like to read the next paragraph?
Yeah, I'm happy to go ahead. Nowhere else does such a rhythm of relaxation find its equivalent. Neither the human nor the geographical world can produce such oscillations of relaxation, with successive fits and spurts of new structures. This relaxation time is the technical time, properly speaking. It can become dominant with respect to all other aspects of historical time, to the extent that it can even synchronize other rhythms of development and appear to determine the entire historical evolution, when in fact it only synchronizes and brings about its phases. An example of this evolution following a rhythm of relaxation can be found in energy sources since the 18th century. A large part of energy deployed during the 18th century came from waterfalls, displacements of atmospheric air, and from animals. These types of prime movers corresponded to artisanal exploitation, or rather, limited factories distributed along waterways. From these artisanal factories emerged the high-efficiency thermodynamic machines at the beginning of the 19th century, and the modern locomotive, which is the result of the adaptation of Stephenson's valve gear to the multi-tubular design by Marc Seguin, lighter and smaller than a French boiler. This valve gear allows for the variation of the relation between admission time and expansion time, as well as the ability to reverse gears, the reversal of steam. Through the intermediary of neutral position, this artisanal type of machine and mechanical invention which grants it to the traction energy the capacity to apply with itself ample variations of the energy torque to highly varied profiles, at the cost of loss of efficiency only in the high power regime, where the time of emission is almost equal to the totality of the expansion stroke, makes thermal energy easily adaptable to traction on rails. Stephenson's valve gear and tubular boiler, which are elements that emerged from the artisanal ensemble of the 18th century, entered into new individuals of the 19th century, especially through the form of the locomotive. High tonnage transportation, which had now become possible throughout all regions, and which was no longer constrained to the contour lines and engineering of navigable tracks. Led to the industrial concertation of the 19th century, which not only incorporates the individuals whose functioning principle is based on thermodynamics, but it is essentially thermodynamic in structure. It is therefore around coal source of thermal energy and close to the site of greatest deployment of thermal energy, coal mines and ironworks, that the great 19th century industrial ensembles at the peak of their reign are concentrated. We have gone from the thermodynamic element to the thermodynamic individual, and from the thermodynamic individual to the thermodynamic ensemble.
So this is an example of this process of evolution that he describes. So starting from these elements in the steam engine, they're incorporated into individuals like a high tonnage train, and then these individuals are incorporated into an ensemble formed of the coal mine and the rail system and the factory.
Yeah, I had one question though. I think, one second. He says high tonnage transportation, which had now become possible throughout all regions, and which was no longer constrained to the contour lines of engineering navigable tracks, led to the industrial concertation of the 19th century, which not only incorporates individuals whose functioning principle is based on thermodynamics, but it is thermodynamic in its structures. Its structure is therefore around coal or source of thermal energy and closely related to the sites of thermal energy. Blah, blah, blah. It goes on to there. But I mean, this key line here, I think I'm struggling a bit with it, whose functioning principle is based on thermodynamics, but is essentially thermodynamic in a structure. So I mean, I'm a bit lost. What do you mean by individuals whose functioning principle is based on thermodynamics?
So here he's talking about the steam engine, which is thermodynamic, or the functions on thermodynamic principles. So it involves the expansion and contraction of different gases based on heat. So it's the steam engine functions on thermodynamic principles. So the individual locomotive or the machine in a factory are thermodynamic individuals. And then they're incorporated into this thermodynamic ensemble because the whole system is structured around the sources of coal. So you have these railway networks and concentrations of factories around coal mines and so on.
All right, I'll read the next part then.
Well, maybe we can see if someone else who hasn't read wants to join in. Anyone?
Sure, I can go. The principal aspects of electrotechnics will in turn emerge as elements produced by these thermodynamic ensembles. Before acquiring their autonomy, the applications of electrical energy emerge as a highly flexible means for the transmission of energy from one place to another by way of energy transport cables. Metals with high magnetic permeability are elements that are produced by way of the application of thermodynamics to metallurgy. Copper cables and high-resistance porcelains for insulators emerge from steam-powered wire mills and coal furnaces. The metallic frameworks of pylons as well as the cement for dams are both born out of great thermodynamic concentrations and enter as elements into the new technical individuals that the turbines and alternators are. A new wave and a new constitution of beings become emphasized and concretized. In the production of electrical energy, Graham's machine gives way to the polyphase alternator. The direct current of early energy transport gives way to alternative currents with constant frequency, adapted to being produced by thermal turbine and consequently also produced by hydraulic turbine. These electrotechnic individuals have integrated themselves into the ensembles of the production, distribution, and utilization of electric energy, whose structures differ vastly from that of thermodynamic concentrations. The role played by the railway in this thermodynamic concentration is now replaced by the role played by high voltage transmission lines in the ensemble of industrial electricity.
All right, so we had the example in the last paragraph of this process of evolution happening in the thermodynamic system, where you have elements, individuals, and ensembles structured in this thermodynamic way. And here we have the same evolution happening in the electrical system. So you have individual elements like the copper cables and the porcelain and so on that are incorporated into individuals, and then they're incorporated further on into these ensembles. So you have a new system of electrical transmission, which differs from the system of the railway lines and the thermodynamic system. Okay, we can go on to the next paragraph. Anyone else like to read?
I can go forward. So, at the moment in which electrical techniques reaches its full development, it produces new schemes in the form of elements that initiate a new phase. First, there is particle acceleration, initially realized through electric fields and then through continuous electric fields and alternating magnetic fields, which leads to the construction of technical individuals. Having enabled the discovery of possibility of exploiting nuclear energy, subsequently and quite remarkably, there is a possibility, afforded by electrical metallurgy, of extracting metals like silicon, which allows the transformation of the radiant energy of light into electric current with an efficiency that already reaches a level relevant for limited applications, 6%, and which is not much lower than that of the first steam engines. A pure silicon photocell, produced by large industrial electrotechnical ensembles, is the element that hasn't yet been incorporated into a technical individual. It is still only an object of curiosity situated at the extreme end of technical possibilities of the electrometallurgy industry, but it is possible that it may become the point of departure for a new phase of development, analogous to the one we have experienced with the development of the production or utilization of industrial energy, which itself is not yet complete.
So yeah, he's giving indications here of a new cycle of this evolution, which he's pointing to early photoelectric cells. And so it's interesting that this has, of course, developed quite a bit since his time. So I don't know too much of the technical details to know whether the example he's pointing to is the source of further developments that we see happening today or not. If anyone else knows more about that, that would be interesting to hear about.
Yeah, I found the Wikipedia link for electrometallurgy. It sounded cool. I had no clue what it was. So electrometallurgy is like a method that they use electrical energy to produce metals by electrolysis, and so it's electrometallurgy is like usually the last stage, as Wikipedia says, in metal production, is therefore preceded by pyrometallurgical or hydrometallurgical options. The electrolysis can be done on molten metal oxide, which is used to produce, as for example, to produce aluminium from aluminium oxide via a pyrolytic process. Electrolysis can be used as a final refining stage in the pyrometallurgical metal production, and is used for the reduction of metal from an aqueous metal salt solution produced by hypermetallurgy. There's a lot of metals there.
Yeah, I mean, my understanding based on this passage is just that they use electricity to separate different metals out of an ore. Like this is what they do to produce aluminum from bauxite, which is why a lot of it happens near hydroelectric dams where they have access to a lot of electrical energy. Okay, so we can go on to the next paragraph. I'll read. Every phase of relaxation is capable of synchronizing minor aspects of those of almost equal importance. The development of thermodynamics thus went hand in hand with railway transportation, not simply with the transportation of coal, but of passengers. On the contrary, the development of electrotechnics went hand in hand with the development of automotive transport. The automobile, albeit thermodynamic in principle, uses electric energy as an essential auxiliary, in particular for ignition. Industrial decentralization, facilitated by long-distance electrical energy transfer, needs the automobile as a corresponding means for the transportation of people to locations that are distant from each other and at different altitudes, corresponding to the road rather than the railway. The automobile and the high-voltage line are parallel technical structures that are synchronized but not identical. Electrical energy cannot currently be applied to automobile traction. So within this cyclical process of evolution, you have different aspects that can be coordinated with each other. So in the same way, so in the thermodynamic system or in the thermodynamic cycle, you had passenger transport was conducted on trains the same way as freight transport. So they were part of the same network. Whereas in the electrical cycle, you have the automobile, which runs on thermodynamic principles, but contains electrical components as an essential part of its functioning. Yeah, and then we'll see in the next paragraph discussion of the new cycle that he sees starting as he's writing in the 50s. So would someone like to read the last paragraph of the section?
Yeah, I don't mind going ahead. Furthermore, there is no intrinsic relation between nuclear energy and energy derived from the photoelectric effect. These two forms are nevertheless parallel, and their developments are susceptible to mutual synchronization. Nuclear energy will thus probably remain for a long time to come inapplicable to direct forms of restricted utilization, such as those consuming a few dozen watts. Photoelectric energy, on the contrary, is a highly decentralizable energy. It is essentially decentralized in its production, whereas nuclear energy is essentially centralized. The relation that existed between electrical energy and the energy derived from the combustion of gasoline exists once more between nuclear energy and photoelectric energy, perhaps with a more accentuated difference.
So again, he's pointing to developments that are just starting in the 50s. So the development of nuclear energy and solar energy are just starting. And it's interesting that this development didn't really take off the way that he maybe anticipated. So, well, nuclear energy has spread, but it has not replaced fossil fuels in the production of electricity because, well, for a number of reasons. The cost of construction and some of the famous disasters like Chernobyl and so on have made it much harder to produce nuclear power plants than I think probably people anticipated at this time when he's writing. And then solar energy is only just sort of starting to become competitive with fossil fuels. So the cycle, the electrical cycle that he describes here lasted longer than I think he thought it would. All right, so that's the end of section 4 of the chapter. So the basic concept introduced here is this cyclical evolution of technical objects. So through the cycle of elements to individual to ensemble, and then a new element, and so on. So that's the general concept of section 4. So we can go on to section 5, which is a bit longer, about 10 pages. So that should probably take us to the end of our session today. So I can start reading. Section 5, Technicity and Evolution of Technics, Technicity as Instrument of Technical Evolution. The different aspects of the technical being's individualization constitute the center of an evolution, which proceeds via successive stages, but which is not dialectical in the proper sense of the term, because, in regard to it, negativity does not play the role of an engine of progress. In the technical world, negativity is a lack of individuation, an incomplete junction of the natural world and the technical world. This negativity is not the engine of progress, it is rather the engine of transformation. It incites man to seek new, more satisfactory solutions than those he possesses. This desire for change, however, does not happen directly within the technical being. It happens within man as inventor and user. This change, moreover, must not be confused with progress. A change that is too abrupt is contrary to technical progress because it prevents the transmission in the form of technical elements of what an age has acquired to the one that follows.
So I'm just going to read this part again. In this technical world, negativity is a lack of individuation, an incomplete junction of the natural world and the technical world. This negativity is not the engine of process, but is rather the engine of transformation. It incites man to seek new, more satisfactory solutions than those he possesses. So, I mean, so at least there's like a theory of evolution in this regard, but in terms of clarification in this context, at least, and he uses the word a lot, like in other times. Like, how is he using the word individuation?
Right. So individuation. So this has to do with what we saw in the first chapter on concretization. So an individual, a technical individual, is an entity that has components that are integrated in such a way that they all function together. So all of the different, a technical object is more individuated to the extent that the different functions of its components are all integrated into the overall functioning of the object. So it's more concrete in that sense, in the sense that all of its internal relations are all part of the overall functioning of the object. And then what is also characteristic of an individual, a technical individual, is that it has an associated environment. So he mentions here the junction with the natural world. So insofar as a technical object is individuated, it will be able to function without self-destructing in a certain environment. So a less concrete technical object or a less individuated technical object is dependent on a very specific environment, like a laboratory or a test track or something like that. Whereas a more individuated and a more concrete technical object will be able to survive in a broader range of environments without destroying itself.
I have a question about that, or a comment. Earlier in the book, he was making a distinction between abstraction and concretization of the concrete. So does that mean when he was talking about abstraction as something negative, as a form of incompleteness in the technical object, was he also talking about negativity then in a more logical sense? That makes me think.
Yeah, that's an interesting question. I think in general, the category of negativity is not one that he sort of thematizes very much. Like it's not a central concept of his work. And so we see here in this paragraph that we just read, he's distinguishing this process of evolution that he's identifying from a dialectical process, precisely because it's not negativity that serves as the motor of progress in the evolution that he's identified. So when he talks about abstraction as a lack or incompleteness in a technical object, you can identify that as a sort of negativity, but it's not an internal negativity in the sense of a dialectical process. It's a negativity in the sense of a lack of adjustment between the object and its environment, which, as he points out here, and then it requires a human intervention from outside to understand this lack of adjustment and to imagine, using the process of imagination, to invent a new technical structure that will be more concrete and that will have a better adjustment with the environment.
We should also maybe throw in the word hypertelic is also functioning here, where it's if something's overfitted to its environment in such a way where it's either too specialized or not specialized enough, then it's hypertelic and it needs to be further concretized. Right.
We saw that last week, where he talks about how an over-specialized technical object is not an instance of progress. So more specialization is not necessarily progress in the sense that a technical object that is hyper-specialized to one specific environment that can only function in a certain environment is less concrete than a technical object that has the capacity to function within a broader range of environments. Are there any other questions or comments? Okay, and then someone would like to volunteer to read the next paragraph.
Sure, I can go again. For progress to exist, each age must be able to pass on to the next age the fruit born of its technical effort. What is capable of being passed on from one age to another are neither technical ensembles nor even individuals, but the elements that these individuals, grouped as ensembles, were able to produce. Thanks to their capacity of internal intercommutation, technical ensembles, in fact, have the possibility of going beyond themselves by producing elements that differ from their own. Technical beings are different from living beings in many respects, but they differ essentially in the following respects. A living being engenders beings that are similar to itself, or that can become so after a certain number of successive reorganizations occurring spontaneously if the required conditions obtain. A technical being, on the contrary, does not have this capacity. It cannot spontaneously produce other technical beings similar to itself, despite the efforts of cyberneticians or cyberneticists who have tended to force technical beings to copy the living by constructing beings that are similar to them. This possibility is currently a mere supposition and is without foundation, but the technical being has greater freedom than the living, afforded to it by its infinitely lesser degree of perfection. In these conditions, the technical being can produce elements that harbor the degrees of perfection at which the technical ensemble has arrived at, and which, in turn, can be reunited to enable the construction of new technical beings in the form of individuals. There is thus no engendering here, no procession or direct production, but only indirect production through the constitution of elements that contain a certain degree of technical perfection.
So this is basically a restatement of what we saw in the last section about the cyclical evolution of technical objects. Whereas living beings reproduce from individual to individual, technical beings reproduce from an ensemble. An ensemble produces an element which is incorporated into a new individual, which is incorporated into a new ensemble, which produces new elements, and so on. So it doesn't have the same process of reproduction of similar entities from old entities. But what's new here, or what the new concept is going to develop as we continue, is this idea of the perfection, of a degree of perfection of technology. This technical progress incorporates existing elements with a certain degree of perfection and incorporates them into new technical individuals and so on that will have a higher degree of technical perfection.
So it seems there is a little room for sci-fi speculation here that this passage gives us, I guess, too. He's talking about cybernetics and how it aspires to reproduction by the machines of themselves, of their copies, right? Or maybe we can see a certain prefiguration of singularity as it's being talked about these days in transhumanist circles.
Yeah, I know that's something that has been talked about in AI and transhumanism, about having AI systems that would be able to develop new AI systems and have a sort of takeoff of progress beyond anything that humans would be able to understand. There's also a similar idea in the world of 3D printing, of having a 3D printer that you could a design for a 3D printer that could itself be printed on a 3D printer. So you could have, once you get the process started off, you can just reproduce 3D printers just through this continuing process of 3D printing new printers. But to my knowledge, this is not possible yet, but it might not be that far away. Oh, and yeah, Lathe Mason just posted in the chat an article about self-assembling robot cubes, which looks interesting. I'm not very familiar with it, but something we can check out after today's session.
Sounds interesting.
Would someone like to read the next paragraph?
Oh, where are we up to today?
Oh, yeah, hi 61.
Hello.
We're on page 72 right now.
This affirmation?
Exactly.
Okay. This affirmation requires that we specify what the process of technical perfection is. Empirically and externally, one can say that technical perfection is a practical quality, or at the very least, the material and structural basis of certain practical qualities. In this way, a good tool is not simply one that is well put together and well crafted. In practical terms, and I can't say this word, ads, is that how you say that? Ads, I'm going to say ads. In practical terms, an adze can be in poor condition, blunt, and yet not be a bad tool. An adze is a good tool if, on the one hand, it has a curve suited for a straight, well-aimed strike at the wood, and on the other hand, if it can be sharpened and keep its sharpness even when employed to work on hard wood. This latter quality in turn results from the technical ensemble employed to produce the tool. It is because it is a fabricated element that the adze can be made of a metal whose composition varies at different points. This tool is not only a hunk of metal shaped into a certain form, it has been forged, which is to say that the molecular chains of the metal have a certain orientation that varies in certain places, like a piece of wood whose fibers are oriented in the direction that offers the greatest solidity and elasticity, especially in the intermediary parts between the cutting edge and the flat, thick part, which goes from the socket to the cutting edge. This region close to the cutting edge deforms itself elastically, that annoying word, during work, because it acts as both wedge and lever on the piece of wood being chipped off. And finally, the cutting edge has a higher steel content than the other parts. Its steel needs to be hard, but in a proper delimited way, for too much of hard steel in the cutting edge would make the tool brittle and the edge would shatter into splinters. It is as if, in its totality, the tool is made of a plurality of functionally different zones welded together. The tool is made not only of form and matter, it is made of elaborate technical elements according to a certain schema of functioning and assembled into a stable structure through the operation of fabrication. The tool unites within itself the results of the functioning of a technical ensemble. In order to make a good adze, a technical ensemble of foundry, forge, and quench hardening is required.
I was giving an example here of what technical perfection consists in. So in the case of the adze, there are certain qualities that different portions of the tool have to have in order for it to function properly. It has a certain function of shaping wood, and in order to have this function, the different parts of the tool have to have different technical properties. So this is an example of technical perfection. I think the next paragraph is going to help with this as well. So I'll read the next one. The technicity of the object is thus more than a quality of its use. It is that which, within it, adds itself to a first determination given by the relation between form and matter. It acts as an intermediary between form and matter. Here, for instance, as the progressive heterogeneity of the quench hardening in different points. Technicity is the degree of the object's concretization. During the period of wood foundries, it was this concretization that gave Toledo's blades their value and prestige, and more recently led to the quality of Saint Etienne steel. This type of steel expresses the result of the functioning of a technical ensemble, comprising in equal measure the qualities of coal used, as well as the temperature and chemical composition of the soft water of the Huron River, or the species of green wood used to stir and refine the molten metal prior to casting. In certain cases, technicity becomes predominant with respect to the abstract aspects of the relation between matter and form. A coil spring is thus a very simple thing in form and matter, yet the fabrication of springs requires a high degree of perfection in the technical ensemble that produces them. The quality of individuals, such as an engine or an amplifier, often depends much more on the technicity of simple elements, valve springs for instance, or a modulation transformer, than on the ingenuity of their assembly. Technical assemblies, however, that are capable of producing certain simple elements, such as a spring or a transformer, are sometimes extremely vast and complex, and are almost coextensive with all the ramifications of several global industries. It would not be an exaggeration to say that the quality of a simple needle expresses the degree of perfection of a nation's industry. This explains why there are judgments that are legitimate enough in both practical and technical terms, such as when a needle is specifically called an English needle. Such judgments have a practical sense, because technical ensembles express themselves in the simplest element they produce. This mode of thought, of course, exists for other reasons besides those that legitimate it, and particularly because it is easier to qualify a technical object by its origin than to judge its intrinsic value. What we have here is a phenomenon of opinion, but even if this phenomenon gives rise to numerous exaggerations or intentional exploitation, it is not without foundation. So he's going on further developing this concept of the technical perfection of a technical object, and so he's explaining that the technical perfection of an element can be the results of a very complicated. So it can be a simple element, but it can be the result of a very complicated technical ensemble. So the spring, for example, is composed of whatever metal, stainless steel or whatever it is. It's a fairly simple matter, and it's made into a fairly simple form, but the process of production involves a very complicated technical ensemble. See you, Varun. And then we have, again, in the other direction, the technical perfection of an individual or an ensemble can also be the results of the perfection of the technical elements. So like a radio, the quality of a radio can depend on the quality of the valves or whatever other elements are inside it, rather than the sort of general structure of the object. Okay, so who wants to read the next paragraph?
I can do the next one. So, technicity can be considered a positive aspect of the element, analogous to the self-regulation exerted by its associated milieu in the technical individual. Concretization is a technicity at the level of the element. It is the reason why an element is really an element produced by an ensemble, rather than being an ensemble itself or an individual. This characteristic makes it detachable from an ensemble and frees it so a new individual might be constituted. There is, of course, no peremptory reason why one would attribute technicity only to the element. The associated milieu is a depository of technicity at the level of the individual, just as exertion is a depository of intercommutativity at the level of the ensemble. It is nevertheless good to reserve the term technicity for this quality of the element, which expresses and preserves what has been acquired via a technical ensemble, so as to be transported into a new period. What the element transports is a concretized technical reality, whereas the individual and the ensemble contain this technical reality without being able to transport and transmit it. Elements have a transductive property that makes them the true bearers of technicity, just as seeds transport the properties of a species and go on to make new individuals. It is thus within element that technicity exists in the purest way, in the free state as it were, whereas in the individual or the ensemble, technicity only exists in the state of combination. Actually, can I just read on since it seems to be in the same train of thought?
Sure.
However, this technicity born by the elements contains no negativity, and no negative conditioning intervenes in the moment of production of elements by the ensembles or of individuals by invention, which reunites the elements in order to form individuals. Invention, which is a creation of the individual, presupposes in the inventor the intuitive knowledge of the element's technicity. Invention occurs at this intermediate level between the concrete and the abstract, which is a level of schemas and presupposes a pre-existence and coherence of representations that covers the object's technicity with symbols belonging to an imaginative systematic and an imaginative dynamic. The imagination is not simply the faculty of inventing or eliciting representations outside sensation. It is also the capacity of the prediction of qualities that are not practical in certain objects, that are neither directly sensorial or entirely geometric, that relate neither to pure matter nor to pure form, but are at this intermediate level of schemas.
Yeah, so this is I think an important passage in this section. So it's looking at so we see here first the argument that, or sorry, first he's differentiating between two different usages of the term technicity, so a broader use and a more restricted use. So in the broader sense, you can say that an individual, technical individual, or an ensemble has technicity in a certain respect, but he wants to focus on this more restricted use where technicity is reserved for a property of the element. So the element has technicity insofar as it can be detached from an individual or an object and then be incorporated, detached from an individual or an ensemble and then incorporated into a new individual and ensemble. So something like a vacuum tube, for example, which might be part of a radio, but you can use it in a computer instead, if we're talking about 1950s technology. So that's the first point in that first paragraph. And then the second paragraph, he's looking at this, the manner in which a technical element is the bearer of technicity. So again, he points out that this is not a form of negativity in the sense of a dialectical evolution. It's through the process of invention, so it requires a human being outside of the element to use imaginative powers, so to operate at the level of the schema, so to represent the elements not merely as geometrical objects, but as objects that have a certain dynamics that operate over time. So using that imaginative capacity to invent a new technical individual that incorporates the functioning of those elements. So that's an important aspect of his theory of technical evolution. Yeah, who wants to read the next paragraph?
I can go on. We can consider the technical imagination as being defined by a particular sensitivity to the technicity of elements. It is this sensitivity to technicity that enables the discovery of possible assemblages. The inventor does not proceed ex nihilo, starting from matter that he gives form to, but from elements that are already technical, with respect to which an individual being is discovered as that which is susceptible to incorporating them. The compatibility of elements in a technical individual presupposes the associated milieu. The technical individual must therefore be imagined, which is to say presupposed as already being constructed in the form of an ensemble of ordered technical schemas. The individual is a stable system of the technicities of elements organized as an ensemble. What is organized are these technicities, as well as the elements as basis of these technicities, not the elements themselves taken in their materiality. An engine is an assemblage of springs, axes, and volumetric systems, each defined by their characteristics and their technicity, not by their materiality. Thus, a relative indeterminacy can subsist in the localization of this or that element in relation to all the others. The location of certain elements is chosen more by virtue of extrinsic considerations than by intrinsic considerations of the technical object in relation to the diverse processes of its functioning. The intrinsic determinations, based on the technicity of each element, are those which constitute the associated milieu. This associated milieu, in turn, is the concretization of the technicities contributed by all the elements in their mutual reactions. Technicities can be thought of as stable behaviors expressing the characteristics of elements, rather than as simple qualities. They are powers in the fullest sense of the term, which is to say capacities for producing or undergoing an effect in a determinate manner.
So again, this is what he was referring to in the last paragraph, where he described how the imagination has to conceive the technical elements in a dynamic way. So it's not the element as a certain material object that is incorporated into an individual. It's an element insofar as it has various capacities to produce an effect or to undergo a certain effect. Though it's that technicity is that set of capacities of that element, and it's those technicities that are organized into an individual, not the element as a material object.
The line in the fourth last line that says technicities can be thought of as stable behaviors is really illuminating. But yeah, just a comment on that.
Yeah, that's I think an important. It's almost it's basically a definition of what he means by technicity. So the stable behavior of a technical element is its technicity, and it's that technicity that is incorporated into the structure of a technical individual.
Yeah, this is interesting. I know I missed some of the early part of the chat today, but has he discussed dispositions or powers before this?
No, this is the first introduction of that concept.
Okay. It seems like he's taking a kind of pan-dispositionalism in the sense that he's taking like all technicities to be properties that are that have dispositional essence, so to speak, or that he's reducing technicity entirely to dispositions, or I mean, I'm comfortable with the powers language for dispositions as well, coming from my readings on power ontology and things of that nature. It seems that the considering what something's power is to be what it is, its disposition is. There are some people that disagree with this in certain ways, but I think that it covers enough cases to be largely what we mean by powers is dispositions in this regard. Of course, I guess there's some sense of power which might not be captured by that, but this is probably a different debate.
Yeah, I know there's a field of literature that I'm a little bit familiar with in analytic philosophy of the ontology of powers or dispositions, and I think those terms are generally used interchangeably. And so in this text here, so he uses the word power in French is puissance, but disposition I think works as a synonym as well. So yeah, he's conceiving of the technical properties of elements as dispositions. So it's a capacity to produce an effect or to undergo an effect in a certain way. So it's not the technical properties of an element are not static properties in the sense of their geometrical configuration or something like that. They are dynamical properties, so they're based on a capacity to do something.
But it's interesting that they're considered to be intrinsic determinations. So they're well, if I'm reading this correctly, let me make sure.
If I may put in, intrinsic also involves relation here, right?
Yeah, so he's distinguishing between, so in the structure of a technical individual, he's distinguishing between intrinsic determination and extrinsic determination. So the structure of an engine, for example, certain internal relations of components are intrinsic, so they have to do with the functioning of the engine as a whole, sort of independently of its environment, and then certain other aspects of its structure might be extrinsic. So it might be certain parts might be placed in one portion of the engine as opposed to another because of the shape of the car that the engine is being put into, rather than because of the functioning of the engine itself. So those would be extrinsic determinations. So yeah, that distinction between intrinsic and extrinsic operates at the level of the individual.
Does it function also at the level of the ensemble, in the sense that individuals need to be set into, technical individuals need to be set into different zones, like he was saying earlier, or does that suggest that they are extrinsic to one another?
Yeah, that's an interesting question. It's not clear from this paragraph whether there's such a thing as intrinsic and extrinsic determinations in an ensemble. But yeah, I think maybe we can make an extension of the use of the concepts here in this paragraph. I would think that so an ensemble operates in a certain environment, for example. So you could have extrinsic determination of the ensemble by the environment, or you could have intrinsic determination based on the interaction of the individuals within it. So I think that would make sense.
But the ensemble is just the organization of the technicities, which are related to intrinsic determinations, which are constituted by concretization of the technicities contributed by the constituent elements. Sorry, that was probably not the most well grammaticized way to talk about that, though. I'm trying to piece it all together.
Yeah, I totally, that description fits for me, with the exception of the fact that like he talks in places where individuals need explicitly to be isolated from each other in order to function as an ensemble. So he gives an example of a recording studio somewhere where, in order for the electricity to not interfere with the recording, you actually need to be careful about how you isolate certain technical individuals that are participating in the recording studio such that they can fit together as an ensemble.
Oh, right, yeah, I recall that from like the sandbox, the safety zone, where you kind of can see the intrinsic determinations of the element, the technicities contributed by the elements, without I guess without the or do you avoid the assemblage within that kind of organization, or is it just the assemblage is not preset or something like that? Or is it that that there is some kind of assemblage which always has to be preset and imagined, as this paragraph kind of indicates? Or wait, or is it the technical individual must be imagined? But is this the ensemble, or the ensemble is the group of individuals? Or because, okay, so there's elements, there's ensembles, and then there's individuals. And maybe I'm just not entirely sure how they all relate to one another.
Right. We discussed this a little bit before you joined. but so it's a 3-level account. So the elements are the lowest level; they're below the level of the individual, and then the individual is composed of elements that are integrated in this concrete way that we saw in the first chapter. So an individual is composed of elements in such a way that their functioning is integrated into the functioning of the individual. All of the relations between the components contribute to the functioning of the individual. And then an ensemble is an organization of individuals, so it's not itself individualized. It contains individuals, but it's not itself individualized. So yeah, the recording suitcase is an example of that, because each of the components is isolated from each other. It only has one relation to the other components, whether it's like a mic cable or whatever it is, connecting one to the other. But except for that one relation, they're supposed to be isolated from each other.
Right. This makes a lot of sense to me within the context of the kind of 19th century syllogistic thinking of the universal and the particular, and the individual as mediating the universal and the particular. So that's easy to remember. That's good.
Okay, so I think we can go on to the next paragraph if someone would like to volunteer to read.
I could try.
Sure, go ahead.
The higher the technicity of an element, the more the margin of indeterminacy of this power diminishes. This is what we want to express when we say that the elementary technical object concretizes itself as its technicity increases. One could thus name this power a capacity if one intends to characterize it in relation to a determinate deployment. Generally, the higher the technicity of an element, the wider the conditions of deployment of this element are, as a result of the high level of stability of this element. The technicity of a spring increases when it is capable of bearing higher temperatures without losing its elasticity, when it preserves its coefficient of elasticity without significant modification within larger thermal and mechanical limits. It technically remains a spring, but within a much larger framework, and is suited to a less restricted incorporation into this or that technical individual. An electrolytic condenser has a lower degree of technicity than a dry dielectric condenser, such as paper or mica. An electrolytic condenser, in fact, has a capacitance that varies as a function of the voltage to which it is submitted. The thermal limits of its utilization are more restricted. At the same time, it varies when submitted to constant voltage, because the electrolytes as well as the electrodes become chemically altered during the course of their functioning. Dry dielectric condensers, on the contrary, are more stable. Nevertheless, the technical quality once again increases with the independence of its characteristics from the conditions of utilization. A mica condenser is better than a paper condenser, and the vacuum condenser is the best of all, since it is not even subject to the condition that the voltage be limited, lest the insulation risk perforation. An intermediary degree, the ceramic silver-plated condenser, for instance, which hardly varies with temperature, and the air condenser, both provide a high degree of technicity. It must be noted that in this sense, there is not necessarily a correlation between the commercial price of a technical object and its elementary technical quality. Very often, considerations of price do not intervene in absolute terms, but via another requirement, like that of space. An electrolytic condenser is thus preferred to a dry dielectric condenser, where its high capacity would require too much space to house the condenser. Similarly, an air condenser is often cumbersome with respect to a vacuum condenser of the same capacitance, although it is much cheaper and is equally safe to deploy in a dry atmosphere. Therefore, in many cases, economic considerations do not intervene directly, but through the repercussions that the degree of concretization of the technical object has on its deployment in an individual ensemble. It is the general formula of the individual that is subjected to economic repercussions, not that of the element as element. the liaison between the technical and the economic domains occurs at the level of the individual or the ensemble, but very rarely at the level of the element. In this sense, one could say that technical value is largely independent of economic value, and that it can be appreciated according to independent criteria.
Right, so this is an interesting argument in this passage here, that the technical perfection of an element is, to a certain extent, independent of economic considerations. So what makes an element more or less expensive is not necessarily its degree of technical perfection, but other considerations that have to do with how it fits into an individual or an ensemble. So in the example he gives here, the space that it takes up is part of what makes it more or less expensive, rather than its actual functioning as a condenser. Okay, so I can read the next paragraph. Actually, I'll probably do the next two because the next one is short. This transmission of technicity by its elements is what grounds the possibility of technical progress above and beyond the apparent discontinuity of forms, domains, the types of deployed energy, and sometimes even beyond the schemas of functioning. Each stage of development is the inheritor of previous ages, and its progress is all the more certain as each stage tends increasingly and more perfectly toward a state of sole beneficiary. The technical object is not directly a historical object. It is subject to the course of time only as a vehicle of technicity, according to a transductive role that it plays with respect to a prior age. Neither the technical ensembles nor technical individuals remain. Only elements have the power to transmit technicity from one age to another, in the form of an effectuated, accomplished, materialized result. For this reason, it is legitimate to analyze the technical object as consisting of technical individuals, but it is necessary to stress that at certain moments in its evolution, the technical element makes sense in itself, and is thus a depositary of technicity. In light of this, one can establish the foundations of the analysis of the techniques of a human group through the analysis of elements produced by its individuals and its ensembles. Often these elements alone have the power to survive the downfall of a civilization and remain valid witness of a state of technical development. In this sense, the method of ethnologist is perfectly valid, but one could prolong its application by equally analyzing the elements produced by industrial techniques. There's a term here that came up a couple paragraphs earlier that I forgot to discuss, this term transductive. So this is a technical term that he introduces in his other major work, the Individuation in the Light of Form and Information. So a transductive process is a process that occurs through the progressive transformation of a metastable environment. So a metastable meaning it's in a state of relative stability, but its potential is not exhausted. So it's still capable of undergoing transformation. So a transductive process occurs. So his model is the formation of crystals in a saturated solution. So you have a chemical solution, and then you have a seed. So a small crystal starts to form, and then the solution will crystallize at the surface of the seed, and so you'll have progress throughout the solution of a growing crystal. So this is his model for transductive processes in general. So he's in this text here, he's characterizing technical evolution as a transductive process because the elements serves as the seed, and then it restructures the environment around it and creates a technical individual and then a technical ensemble. All right, would someone like to read the next paragraph?
Sure. Or you can go.
Sorry.
Go ahead.
Yeah, we're now in Q. So indeed, there is no foundational difference between the people who have no industry and those who have a well-developed industry. Even in a people without any industrial development, technical individuals and technical ensembles exist. Nevertheless, rather than being stabilized by institutions that fix and perpetuate them by installing them, these individuals and ensembles are temporary or even occasional. What is preserved from one technical operation to another are merely the elements, which is to say tools or certain fabricated objects. To build a boat is an operation that requires a truly technical ensemble, a fairly flat ground yet close to the water, sheltered yet luminous, with supports and wedges to keep the ship standing while it is being built. The shipyard, like the technical ensemble, can be temporary. It is no less than a shipyard constituting an ensemble. Even today, similar temporary techniques in some ensembles still exist, sometimes even highly developed and complex ones, such as the construction sites of buildings. Others are provisional while being durable, like mining facilities or the drilling rigs for oil exploration.
Slight translation note here, and so the sentence, the shipyard like the technical ensemble, it should be translated as the shipyard as a technical ensemble. That makes more sense in the context. Yeah, so we see here a further extension of the concept of a technical ensemble. So so far he's been discussing it in the context of Western industrialized society, but he's giving examples here of how you can apply the same concept in non-industrialized societies. So the production of a boat requires this ensemble that consists of the flat surface and with access to water. And you could add, it has to be close enough to sources of wood or whatever other materials are used for the production of the boat. But yeah, so that you have a technical ensemble even in a non-industrial society.
This is kind of interesting because it kind of sets aside questions of historically loaded kind of phases of technicity. He's kind of flattening technical objects and technicity out such that the historical practices, which we don't think of as technological, are still technological, and in the same way that the technological processes of contemporary society are. So he says that even without any industrial development, the technical individual and the technical ensemble exists. So here he's kind of taking some of the wind away from a lot of the arguments that would say that, like, we are now in this novel technical stage of history, but rather that this technicity is something which transcends historical periods.
Whenever I read his examples talking, I guess trying to talk about how technicity might be employed in other cultures, is like impressed and disappointed at the same time, sort of. That I'm really amazed that in his time he can have, I guess, such a wholesome view of how technicity transposes through time and different can't say anything today, geographical positions, but at the same time the examples that he picked for analyses is just so industrial that I wish he had more analyses of example that does not get limited within that realm.
Yeah, I know how you feel. I'm used to the kinds of examples from other authors on technology that will talk about like traditional mythology and religion as having technicity, for instance. And I find that these are really clarifying because they're somewhat counterintuitive, and they support Simondon's claim that the historical is in some ways kind of untouched by the technical, that the technical, it transcends the historical in a specific kind of way, that we shouldn't be thinking about technical objects as something that is just a recent development or something along those lines.
Yeah, I think specifically what he's arguing here is that this hierarchical structure of the element, individual, and ensemble is transhistorical. So that same structure exists in contemporary industrialized society and also in non-industrialized societies. So it's not specific to any one society.
At this point, frankly, I'm really curious about Simondon's dating life. What does his partner do?
I actually don't know. That is an interesting question.
Yeah, I'm just wondering what would it like to have this person, this theorist, as like a dad or a partner, since he had like 7 kids and obviously enjoyed a lot of protesting and political activity and very sustainable farming activity and such with them. But when I read languages and thoughts like this, I just don't know how he can deliver it in a quotidian manner.
Yeah, I think his sort of personal biography is not very well studied. I mean, he's not sort of as famous as some other 20th century philosophers, so there's not as much biographical material about him. Like, as far as I know, there's no book length biography of him.
Oh, thank you for that link. I haven't been able to find any biographical content, so I'll definitely read that after the group.
Yeah, that's the article that I read that barely told me where he taught and his 7 kids and activism and such. I haven't been able to find anything else aside from that at all.
I think we can go on to the next paragraph if someone would like to volunteer.
That's the one starting not all technical ensembles?
Yeah.
Not all technical ensembles necessarily take on the stable form of the factory or the workshop. On the other hand, it seems that non-industrial civilizations differentiate themselves from ours mostly by the absence of technical individuals. This is true only if what is meant is that technical individuals do not exist materially in a stable and permanent way. The function of technical individualization, however, is assumed by human individuals. The process of learning through which man forms habits, gestures, and schemas of action that enable him to use the highly varied tools that the totality of an operation requires, pushes this man to individualize himself technically. It is he who becomes the associated milieu of these diverse tools. When he masters all of his tools, when he recognizes the moment he must change tools in order to continue working, or to use 2 or 3 tools at a time, he ensures an internal distribution and self-regulation of the task through his body. In some cases, the integration in the ensemble of technical individuals happens via the intermediary of an association of human individuals, working in 2s, in 3s, or in larger groups. When these groupings do not introduce functional differentiation, then their only direct purpose is to increase the available energy or speed of the work. But when differentiation is called for, they clearly demonstrate the genesis of an ensemble on the basis of men employed as technical individuals rather than as human individuals. This was the case with bow drilling or bow drilling, as described by the authors of classical antiquity. It is still the case with the felling of certain trees. It was also commonly the case not so long ago with the use of two-man crosscut saw, a two-man crosscut saw to make planks or rafters, 2 men working together in an alternating rhythm. This explains why, in some cases, human individuality can be used functionally as the basis of technical individuality. The existence of separate technical individualities is a rather recent development and even appears in some respects like an imitation of man by the machine, where the machine remains the more general form of a technical individual. Yet in reality, machines are very dissimilar to men, and even when they function in a way that produces comparable results, it is very rare that they use procedures identical to the work of an individual man. The analogy is in fact most often very external. Yet if man often feels frustration before the machine, it is because the machine functionally replaces him as an individual. The machine replaces man as tool bearer. In the technical ensembles of industrial civilizations, Jobs where several men must work in narrow synchronization are becoming rarer than in a past characterized by the artisanal level. Conversely, at the artisanal level, it is very frequent that certain works require the grouping of human individuals with complementary functions. To shoe a horse, one man is needed to hold the hoof, and another to hold the shoe up and nail it on. In order to build, the mason has his assistant, the hod carrier. In order to thresh with the flail, one needs a proper perception of the rhythmical structures that synchronize the alternate movements of the team's members. Yet one cannot affirm that what has been replaced by machines are only the helpers. It is the very basis of technical individualization that has changed. This basis was the human individual. It is now the machine. Tools are borne by the machine, and one could even define the machine as that which bears and directs tools. Man directs and adjusts or regulates the machine, the tool bearer. He realizes groupings of machines, but does not himself bear tools. Indeed, the machine accomplishes the core work, the work of the blacksmith and not that of the helper. Man, disengaged from this function of the technical individual, which is the very essence of the artisanal function, can now become either organizer of the ensemble of technical individuals or helper of technical individuals. He greases, cleans, removes detritus and burrs. In other words, in some respects, he plays an auxiliary role. He provides the machine with elements, changing the belt, sharpening the drill, or the lathe cutting tool. There is thus, in this sense, a role above that of the technical individuality and one below it, servant and regulator. He supervises the machine, the technical individual, by looking after the relation of the machine with the elements and the ensemble. He is the organizer of relations between technical levels, rather than being himself, like the craftsman, one of the technical levels. A technician, therefore, adheres less to his professional specialization than does a craftsman.
All right, thank you. That was a bit of a long paragraph. So this is some material that I think we saw in the technical mentality paper that we read a few weeks ago. And then also in the introduction to this book, he talks about this a little bit as well. So some of the reasons why machines in particular evoke a certain fear or even hatred in human individuals. So because the machine replaces the individual, the human, at the level of the individual as the bearer of tools, it displaces human workers into these roles either as the supervisor or as the helper, rather than being the bearer of tools and at the level of the technical individual. There's also a footnote that probably worth reading as well. So this was, where does it come in? So it's early in the paragraph, maybe a third of the page down, or about halfway down the page on page 77. So it's when it discusses how the individual is master of his tools. When he recognizes at the moment he must change tools in order to continue working, or to use 2 or 3 tools at a time, he ensures an internal distribution and self-regulation of the task through his body. And then there's the footnote there, which reads, this is where a certain nobility of artisanal work comes from. Man is the bearer of technicity, and work is the only mode of expression of this technicity. The imperative to work translates this requirement of expression. To refuse to work when one possesses the technical knowledge that can only be expressed through work, because it cannot be formulated in intellectual terms, would be to hide one's light under a bushel. The requirement of expression, on the contrary, is no longer linked to work when technicity has become immanent to a knowledge that can be formulated abstractly and outside of all concrete actualization. So we saw this again in the technical mentality paper, the idea that artisanal work has this sort of nobility associated with it, in the sense that the technical knowledge is incorporated into the worker themselves. They are operating at the level of the individual, and the knowledge of the technical process can't be expressed in abstract terms, in linguistic formulations, for example. Whereas when we have industrialized processes where the human doesn't operate at the level of the individual, you instead have knowledge that is incorporated in linguistic terms or in diagrams or something like that, where it's not incorporated into the person in the same way as the artisan. So the work doesn't have that same nobility.
And, or science for that matter, right? And I think I mentioned it in the time of the technical mentality paper too, but that like this very much resonates with Marx's fragment on machines from the Grundrisse.
Right, and that the definition of a machine as the bearer of tools, I'm pretty sure that Simondon is drawing that from Marx, the discussion of machines in Capital, chapter 15.
I'll definitely look at the statements in the Grundrisse. I don't know if I want to look at Capital. My eyes might fall out or something. Just kidding.
I think the Grundrisse is actually harder than Capital, but the one fragment on machines is pretty accessible.
Oh, okay. Okay. Yeah, no, that footnote was definitely very relevant. It almost seems as though the function which work provides is in danger from the abstraction which and from which the craftsmanship limits the expression of the work, the expression as a criteria of the work, such that work can be worked without any kind of non-abstract things. If work can be entirely abstract in the sense of like if I were to imagine a task of intellectual work in which somebody was supposed to do something with abstractions, which did not have any physical or technical or experimental content, then there would be no longer this kind of expressivity within the function of work, and therefore work would lose something which it heretofore had been constituted by, which is this expressivity of artisanal work.
Yeah, this changing function of work, or this transition of work from this artisanal mode to this industrial mode is one of the key problems that motivates this book as a whole. So he wants to he thinks that our culture needs to have a more concrete understanding of technology, needs to integrate understanding of technology at all three levels, at the level of the element, individual, and ensemble, precisely because human work no longer is realized at the level of the individual that incorporates the technicity into its own functioning. So in order to have this relation to work, a non-alienated relation to work, we have to be able to understand the technology at those three levels, rather than just being subordinated to the machine as a helper or supervising the machine from the outside. Okay, so we can go on, I think, to the next paragraph. I can read. This, nevertheless, does not mean that that man cannot be a technical individual in any shape or form and work in conjunction with the machine. This machine-man relation is realized when man applies his action to the natural world through the machine. The machine is then a vehicle for action and information in a relation with three terms: man, machine, and world, the machine being that which is between man and world. In this case, man preserves some traits of technicity defined in particular by the necessity of apprenticeship. The machine thus essentially serves the purpose of a relay, an amplifier of movements, but it is still man who preserves within himself the center of this complex technical individual that is the reality constituted by man and machine. One could say in this case that man is the bearer of the machine, while the machine remains the tool bearer. This relation is thus partially comparable to that of the machine tool, if what is understood as machine tool is that which has no self-regulation. It is man who is at the center of the associated milieu in this relation. The machine tool is that which has no internal autonomous regulation and which requires man in order to make it work. Man intervenes here as a living being. He uses his own sense of self-regulation in order to operate that of the machine, even without the need for it to be consciously formulated. In order to restart an overheating car engine, a man will allow it to rest, and in order to start it back up, instead of beginning by revving it up too much, he will progressively get it started from a cooler state. Such behaviors, which are technically justified, have their correlation in vital regulations and are lived by the driver more than simply being thought by him. They apply all the better to the technical object as the latter approaches the status of a concrete being, encompassing homeostatic regulations within its functioning. For the technical object that has become concrete, there is indeed a regime in which the processes of self-destruction are reduced to a minimum because of the greatest possible degree of perfection in homeostatic regulation. This is the case for the diesel engine, which requires a definite operating temperature and a regime of rotation confined within a narrow margin between minimum and maximum, while the gasoline engine is more flexible because it is less concrete. Similarly, an electronic tube cannot function with a cathode at any temperature whatsoever or with an indeterminate anodic voltage. For power tubes in particular, too low a cathode temperature causes the electric field to snatch electron-emitting oxide particles. Hence the need for a gradual startup, beginning with a warm-up of the cathodes without anodic voltage, followed by the powering of the anodes. If the circuits of polarization are automatic, fed by the cathodic current, then they must be progressively powered through the gradual feeding of the anodes. Omitting this precaution leads to a short instant in which cathodic current already occurs before polarization reaches its normal level. Polarization produced by this current and proportional to it tend to limit it. The cathodic output, which is not yet limited by this negative reaction, would exceed the admissible maximum. So here we have another relation between the human and the machine. So it's not, the machine doesn't always necessarily replace the human worker at the level of the individual. So here we have a relationship where the human operates the machine, and the machine acts as a relay between the human and the world, the external environment. And the human being uses their own functioning as a living being as a model for operating the machine, so allowing the engine to rest, for example.
I think the interesting thing for me is that this kind of behavior can be seen in society as appropriate, where other, nuanced kind of active beliefs also are kind of just shed in the same vein. Really interesting.
Could you expand on that? Like which beliefs, which active beliefs are you thinking of?
So what I meant by that was this type of understanding technicity as an extension of not only oneself, but also kind of society in a way where, robotics can be this mirror kind of society which acts in spirit alongside man, right? Or whatever kind of concept, kind of overlays most media contemporarily. And, kind of like way back, maybe like the advent of science fiction, or when science fiction was really becoming popular with people like, I forget his name, sadly, but he was the guy that really popularized a lot of like this type of like naval science fiction. But the point that I was making was that this kind of behavior, or like this extension of man and spirit into technicity, right, is entirely appropriate in certain circumstances. But then it's, this kind of same concept. Yeah, him. The same concept is not really extended to other things, right? More inanimate things in a way, where, objects or bodies can just be perceived as things that fundamentally don't feel, right? And that might be a kind of callback to a sort of Cartesian notion of the separation between bodies and minds. But, equally so, this kind of mechanistic thinking, which pervades all throughout, contemporary Western society, is, we don't extend a lot of these kind of feeling functions to animals for some reason. And it's really incredibly interesting to see animals as these beings with the inability to speak or convey complex belief, imagination, emotion, or intention, right? And all the while, Americans will refer to their cars as her, or she, or any number of thing that objectifies, further feminizes the vehicle, and then also objectifies women in some way. And I think that that's really interesting, because I think that this is really where a lot of like this kind of thought goes forward in capitalism, is this progression of these pre-existing sentiments, or antagonistic which are antagonistic towards women, like these sentiments that just are so unfounded. I think that that's kind of what I was thinking of, was these are considered appropriate, but things that are inconsiderable in this kind of context is you're not really allowed to actually believe these things to have any spirit or mind in them, right? And you're not even allowed to really extend that to animals in some cases, except for maybe certain domestic species.
If I'm following you, are you kind of thinking of the human's interaction with the technical object as mirroring or mirrored by the human's reaction or relation to other humans? So kind of like a implicit social relation, sort of.
Yeah, is thusly a technology which mediates the relation between man's technology and himself, as well as nature. It goes full circle, yeah. And that is what I was getting at for the most part. That's what was implied in a lot of my stuff. But something I kind of want to bring attention to is that animals are being skinned alive in many parts of the world, and not much care is extended to them. And simultaneously, there is evidence that plants may feel pain, right? And there's evidence that meat may feel pain, even after being severed from, the body or the mind of the animal, right? And it's because of, nervous stimulation. So, people kind of don't really, they're willing to suspend their belief as long as it is conducive to business or the state which they occupy, right? So, and that's kind of like a Baconian concept of like, suspicions or suspension of certain beliefs. It's like, oh, just don't pay any mind to this thing, right? We have to pay attention to this thing because it's the most conducive to our, operation. It's the goal, right? And that's kind of my concern, is like, we might think about these things in certain ways, and they might be entirely. It's like, it's just fucking hilarious to me. It's like Americans will be like, oh, well, let me view some media which engages the senses the same way that reality does, and then let me just throw it away as though it's just some like novelty or like spectacle, right? Where it's just like, oh yeah, I just watched that. Yeah, what did it do for me? Oh yeah, made me believe these things. And then it's like simultaneously they're like, well, that wasn't real. It's like, okay, well, it's kind of like a really super nuanced kind of system there, where any number of aliens engaging or any alien individual, right, engaging in any kind of media like that, they might, or conversing with a person after they both shared some media experience, it's like, what the fuck did they just experience, right? And why is there like a set of actions which are considered appropriate upon viewing this? Or just that's what was interesting me in that. But also the mediation, to keep it on track, the mediation between the technicity and man's relation to technicity, and this kind of second race that comes up with this conception of robotics.
I think that as far as Simondon's perspective is here, he wants to talk about technical objects as sharing a similar logic to the way we talk about life, but without conflating them categorically. At least that's my understanding from what we've read so far. So in a sense, he wants us to be able to think of the technical object as lifelike without fully thinking of the technical object as a form of life itself. So maybe this
that was my question to the topic at hand.
Yeah, I felt that might
why
have been.
Is that appropriate?
Well, I
Sorry,
think
didn't mean to cut you off.
yeah, no, I think that this does actually there is like a kind of ethical imperative in this categorical separation into not confusing the technical object with the object that is alive. Even though I
And
think
this
that it
is constant
go
in most
ahead.
comedies. No, you can. I
Actually,
was just saying it's
could
like
you
constant in
stop
most comedies.
interrupting her in the middle of her sentence? Just let her finish a statement first, because otherwise the conversation is really hard to
No, I'm
follow.
not trying to interrupt. I'm just adding on to what she said. Or I'm
She has yet to
cheerleading.
finish a sentence and you cut her off twice.
I was cheering her.
Yeah, I'm sure it was meant in a positive spirit. But yeah, what do y'all think about the about Simondon's how close he talks about life and human life and the technical object, because it seems like there is this kind of ethical imperative in the background that to think about to conflate the categories of life and technical object would be somehow somehow problematic in a very serious way, and that by talking about the technical object as something which can be lifelike, it can serve to differentiate them rather than conflate them. But I don't know. I can see the opposite way that there. I mean, it definitely if I had a very surface reading of Simondon, I might be worried that there could be this possibility of objectification of life forms by thinking of them as technical rather than lifelike in some way. But I do think that he makes great strides to kind of create a situation in which that ethical differentiation can be manifest. Like he definitely, I don't remember exactly where it was, but he made a stride to dissociate the technical object from the life world object.
Yeah, I think one example.
Go ahead, LA. You cut out, I think.
Yeah, you cut out.
Sorry, that just to say that the moment where he sort of talks about the limitations of the cyberneticists, I think is a good example of precisely what you're saying. That he basically says it's not a simple matter of kind of analogizing from life or evolution over into technical objects, and that the cyberneticists made a serious mistake in doing so. That they are kind of like that they're not observing the kind of ethical boundary that you're describing.
Yeah, I think there's sort of two levels that are operating. So just at the descriptive level, he thinks that it's inadequate, that a purely cybernetic approach to living beings is inadequate descriptively. So it doesn't cover what a living being is in a sufficient way. But then at an ethical level, I think he would argue that our relationship to living beings is different from that to technical objects, but that doesn't preclude the ethical relationship or ethical responsibility towards technical beings. So we saw this in the technical mentality paper as well, where he argues for an ethical relationship to technical objects, like an ethics of non-waste,